Let's do a few examples of a 30, 60, 90 triangle, one of the other special right triangles. In example number 5, it says the shorter leg of a 30, 60, 90 triangle measures 8 inches. Find the lengths of the other sides. Give an exact answer, and where appropriate, approximate to 3 decimal places. Okay, now you get to draw your own 30, 60, 90. You can draw it however you'd like. It doesn't really matter where you put your 30, your 60, or your 90. You just have to make sure that you label your answer correctly. Now, you have to be careful when you start to talk about the relationships and the formulas we use for a 30, 60, 90. If I was looking at the left triangle over here, I know that I have a right angle, 90, I have one of the angles is 30, and the other angle is 60. I remember that the relationship is across from the 30 is always x, across from the 90 is always 2x, and across from the 60 is always x rad 3. But if my triangle was twisted around or looked a little bit different, still though, I would have that same relationship, where across from the 30 is x, across from the 90 is 2x, and across from the 60 is x rad 3. But I have to make sure that I remember it in that order and not kind of clockwise or counterclockwise, because my pictures can look different, right? All right, what does it say in this problem? It tells me that the shorter leg of the triangle measures 8 inches. So it doesn't say anything about the hypotenuse. So we have narrowed it down to either the side across from the 30 or the side across from the 60. Now it says the shorter leg, and so that means the side opposite of the smallest angle. The smallest side is across from the smallest angle. The biggest side is across from the biggest angle, right? That makes sense. So in this problem, it tells us that the shorter side, the one across from the 30, is going to be 8 inches. So I know that this side is 8 inches. Well, right away, then that tells me that x equals 8 inches, right? Well, if x is 8 inches, then that means my hypotenuse is 2 times 8 inches, or I can say 16 inches, right? And if x is 8 inches, then I can say that the side across from my 60-degree angle is 8 times rad 3 inches. Or I can put that in my calculator and say 13.856. No matter which way you draw your triangle, those should be the measurements across from each of those angles. Across from your 30 is x, across from your 90 is 16 inches, across from your 60 is 8 rad 3 inches. All right, let's do another one. In example number 6, it says the length of the longer leg now of a 30, 60, 90 triangle measures 14 centimeters. Find the length of the hypotenuse this time. Okay, here we go. I drew my triangle like this. I don't know why. I've got a 30 degree, I've got a 60 degree, and I know that the relationships are. Across from the 30 is x, across from the 90 now is 2x, and across from my 60 is x rad 3, making sure that I do it in that order. Okay, what does it say? It says the longer leg, so not the hypotenuse and not the leg across from the 30, but the leg across from the 60 is 14 centimeters. So I can set up an equation that says that that side, 14, is also have the relationship of x times rad 3, right? And so I have an equation that says x rad 3 equals 14. And now I can solve for x. I can divide both sides by the square root of 3, and I end up getting x equals 14 over rad 3. But let's go ahead and rationalize that denominator also, multiplying both the top and the bottom by square root of 3. So I end up getting x equals 14 rad 3 over 3, because rad 3 times rad 3 is the square root of 9, which ends up just being 3, right? So if x is 14 rad 3 over 3, and we want to figure out what the hypotenuse is, well, if the hypotenuse is 2 times x, then the hypotenuse is really going to be 2 times whatever x is, 14 rad 3 over 3. You notice that I put the 2 over 1 so that I can see fractions next to fractions. And I know that when I'm multiplying fractions, I multiply across the tops and I multiply across the bottoms, right? So multiplying my numerators together, remember that outsides go with outsides and insides go with insides, I should be able to multiply the 2 times the 14 and say that I have a 28 times rad 3 in my numerator. On my denominator, 1 times 3 is 3. So I can say that my hypotenuse is 28 rad 3 over 3 centimeters. Or I can put that in my calculator and say approximately 16.166 centimeters for my hypotenuse. Knowing those 30, 60, 90, and only one of the sides should help me figure out all the other sides fairly quickly